Welcome back class 9th. Today we'll do question number 3 from exercise 12.2 of your NCERT textbook. Question number 3 has a figure like this, and it says that Radha made a picture of an aeroplane with colored paper as shown in this figure. So you have got 5 areas. Area number 1, which is triangular in shape. Area number 2, which is rectangular in shape. Area number 3, which is a trapezium. Area number 4 and area number 5, which are right angled triangles. You have to find out the total area of paper used, and for the same, what we are going to do, we will identify each of these shapes and apply the suitable formula to find out their areas, and finally we will add up the areas to find out the total area of paper used. Now there's one thing you want to keep in mind. Assuming that the picture is symmetrical, what we can say that the first figure is an isosceles triangle, means the two sides are equal, so these two sides will be equal. Each of these will be 5 centimeters, and the base of the triangle, this, will be equal to the opposite side, which is 1 centimeters. So you can find the area using Heron's formula. Then we move on to the second shape. Now this will be a rectangle. Again, keeping in mind that the picture is symmetrical, what we can observe that this here is a horizontal line and these two are vertical lines. If this is a horizontal line and below we have two vertical lines, that means over here we have right angles. So that makes second shape a rectangle, and its length and breadth are 6.5 centimeters and 1 centimeters respectively. Its area will be equal to the product of its length and breadth. Third shape, over here it is a trapezium. The parallel sides are 1 centimeters and 2 centimeters respectively. The non-parallel sides are equal, so this is an isosceles trapezium. You will find its area like question number 9. Then fourth part and fifth part, they are equal. These two parts, they are identical, and these are actually right angled triangles. So their area will be given by half into base into height. Let's identify the base and the height. So this here is 1.5 centimeters and this is 6 centimeters. In between them is a right angle. So this is the base and this is the height, or you could take this as the base, this as the height. Two sides which contain the right angle are taken as base and height for the right angle triangle. So the area of one triangle can be calculated, and that will be the area of the second right angled triangle. Let's quickly find out the areas and see what our answer is. For the first part, the isosceles triangle, we are applying Heron's formula. So for this triangle, we are applying Heron's formula. Let's start with the semi-perimeter, sum of all sides. This will be 11 by 2. Then area will be equal to under the root s into s minus a, s minus b into s minus c, where s is your semi-perimeter, a, b, c are the three sides. Let's put the values. 11 by 2 into 11 by 2 minus 5 the first side, 11 by 2 minus 5 the second side, 11 by 2 minus 1. Simplify your brackets taking LCM. You get 11 by 2 multiplied by 1 by 2 multiplied by 1 by 2 and multiplied by 9 by 2. So this becomes 11 into 9 in the numerator. In the denominator you've got 4 times 2. Make pairs. The square root of 9 will be 3, and from here there will be 2 pairs. Under the root we have 11 left, so 3 by 4 under the root 11. Root 11 approximately is 3.3. Find the answer. This will be area 1. I'm leaving this for you. Now let's move on to the second shape. The second shape was a rectangle. The area of the rectangle will be given by A equals to the product of length and breadth. Let's find out the area of the second part. Area will be equal to L into B, which is 6.5. The length into the width is 1. So this will be 6.5 centimeters square. Now let's find the area of the third part, which is a trapezium. Now if you want, you can recall question number 9 of exercise 12.2 so that you can do this part. For area of a trapezium, the formula that we have is half into sum of parallel sides into height. Let us draw the height for this trapezium. Let's name the trapezium as A, B, C, D. Let the height be CM. I have the parallel sides as 1 centimeter and 2 centimeters, but I do not have the height of the triangle, which is represented as CM. So I'll be working a little to find out the height, and then I'll apply this formula to find out the area of trapezium. And for the purpose of calculating the height, I'm going to divide my trapezium into 2 parts, one a parallelogram and the other one a triangle. Let's draw a line through C parallel to AD, which will make quadrilateral ADCE a parallelogram. Since this pair is already parallel, this has been done by construction. This becomes a parallelogram, and in a parallelogram opposite sides are equal. I know the length of this side, so the length of the opposite side will also be 1 centimeters. The length of AD is 1 centimeters, and therefore the length of CE will also be 1 centimeters. Comparing it to the figure given over here, this is what I had. So if I draw a line parallel right here, this will be a trapezium, and the opposite sides will be 1, 1. This pair of opposite sides will also be 1 and 1. This is what I have done here. Now the length of this side was also 1 centimeters. Let's find out the length of this portion. Since the total length of this side was 2 centimeters, this will be 2, the whole length, minus AE, which is 1 centimeters. I'm going to work with triangle CEB, in which I have the height CM. Once I've divided the trapezium into 2 parts, a parallelogram and a triangle, with the help of parallelogram I'm able to find out this side for this triangle. I'll be working with this triangle using Heron's formula. So let's draw the triangle separately. CEB, This is 1 centimeters. This is 1 centimeters. The base is also 1 centimeters. Now I need to find out the area of this triangle so that I can find out the height cm. I would have used Heron's formula if it were some other triangle, a scalene triangle or an isosceles triangle, but right now this triangle is equilateral triangle, and for the area of equilateral triangle, the formula to calculate the area is under root 3 by 4 multiplied with side square. This was obtained in first question of first exercise 12.2. The side for this equilateral triangle is 1 centimeters. Solving, so the area comes out to be root 3 by 4 centimeters square. Now using this area I'll find out the height of the triangle. So half into base into height, which is area of triangle. This is obtained as root 3 by 4. Let's put the value of the base. Half, the base of the triangle is 1. Height, you could use h, or you can write down the name of the height cm, equals to root 3 by 5. So height cm comes out to be root 3 by 2 centimeters. Now I can use this height in this formula over here. So the area of trapezium, half into the sum of the parallel sides. The parallel sides were 1 and 2, multiplied with the height obtained, root 3 by 2 over here. This is the height. Simplifying, so this comes out to be 3 times root 3 by 4 centimeter square. So this is the area for the third part. Now let's find out the area for triangle number 4 and triangle number 5, which are right angle triangles, and their areas can be calculated easily using half base into height. So area 4 is equal to half into base into height. Half, the base of the triangle is 1.5 and the height is 6. So this comes out to be 4.5 centimeters square. Similarly, area of triangle number 5 or part 5 equals to the area number 4, which has been obtained as 4.5 centimeters square. And then finally you can find out the total area. Area first plus area second plus area number 3 plus the area number 4 and the area number 5. The area number 1 is approximately 2.475. Area number 2, which was a rectangle, 6.5. Area number 3, which is a trapezium, its area comes out to be approximately 1.2975, and the area 4 and area 5 are 4.5 and 4.5. So the answer for this will be 19.27 approximately, and the units are centimeter square.